or three initial approximations. So what are the three initial approximations? So that are x0, x1 and x2, and then we will update our these approximation values in each iteration. Okay, and how we will replace these three one, we will discuss that one. Okay now. So Muller method actually requires three starting points, x0, x1, x2, and for each point you will get some value of coordinates. Okay now. So f of x2. So you have 3 points, okay, in the two-dimensional coordinates. So you can find you have to find a parabola, okay, passing through this 3 point. Okay, so passing through this 3 point, you have to construct a parabola. Okay, and after finding a parabola, that means actually since you are finding the parabola, you know the general form of a parabola is, that means equation is ax square plus bx plus c. You have, that is y. Okay, you have studied okay. So now you have already studied this type of 4ax square, correct? Or y square equals to 4ax, or x equals to 4ay square. So many form you have studied, but basic actually general form of a parabola, okay, you can write y equals to, or f of x equals to ax square plus bx plus c. So that one actually our target to find that equation. Okay, so quadratic formula is used to find a root of the quadratic for the next approximation. Okay, what is that one? I will discuss. So first consider x0, x1, x2, construct construct a parabola. Okay, then you will get 1 point, okay, another point, okay, and that point you can add here, okay, by replacing one of this one, that is actually you have to replace x0. So first initial approximation x0, x1, x2, the second one will be x1, x2, x3. However, the name will be same again. This x1 will be x0, and this x2 will be x1, and this x3 will be x2. So this is the way you are replacing. This is the new one, x3. Okay, in the next iteration this one will be replaced. Okay, so actually that is the way to replace the new points. So I will write here x0, x1, x2. So this is the initial approximation. Next approximation x1, x2, x3. However, the notation of this one is like x0, x1, x2. That okay. So next one is x2, x3, x4, and so on. So each iteration, this is the first approximation solution. This is the second iteration. However, for okay, it will be x0, it will be x1, it will be x2. Here it is x0, it is x1, it is x2. So in that way we will proceed. Okay now, and each time you are updating only one, that means you are changing only 1 point. Rest 2 points will be the same. Okay, so this is the process. So initial approximation, okay, first iteration you can say this is the second iteration, and so on. So now that is the third one. Okay, now since you have 3 points, okay, so for this 3 point we will consider, okay, just 1 minute, yeah, what is going on, yeah, so we will consider the parabola in this form, f of x equals to a into x minus x1, okay, x minus x1, okay, a into x minus x2 whole square plus b into x minus x2 plus c. So it is also quadratic equation of x. Okay, and to reduce the calculation, okay, now calculation hazard, we actually written like that. So 3 points x0, x1, x2, Okay, we already used x2, okay, to write the initial form of the parabola. Okay, so now what is the actually graphical concept of this 3-point method? Okay, so the graphical concept of this 3-point method is this one. Okay, here is it visible? Okay, so earlier what we did actually for one point, it is that bisection method we have studied, and we have already studied, and that Newton-Raphson for single point approximation, and then regular falsy 2-point. Okay, if we consider only 2 points, okay, then what we did actually earlier, just connecting that 2 points, say the x0 and x2, only 2 points are there, then this is the process to find the, so this point will be the new point. Okay, and the formula is, or the method name is regular falsy, correct now? Okay, so that is 2-point formula. Now you have 3 points, so you have to construct a parabola. This is the parabola, okay now? So this is the parabola, okay, this line, so blue one. So this is the parabola, and now x0, x1, x2, okay, the new, that is the initial approximation, this is the root, estimated root, new estimated root, correct? So now you have to, this one should not be considered in the next iteration, x1, x2, and this is say x3, so this is say x3. So the next iteration is x1, x2, x3. Initial approximation, you just see, I will erase everything, this one, x0, x1, x2. Then you have drawn one parabola. Okay, so this is the parabola, I think you can, this is the parabola, okay now? So that parabola is actually crossing the x-axis, say this is the point, that is known as root estimate, that is x3, say, okay, say x3. Then, so this x3 is the new entry. So you have to, since it is 3-point formula, you should, you can't handle that x0, x1, x2, x3. So you have to remove this one. So the new entries are x1, x2, sorry. The new entries are x1, x2, and x3. And since your formula in terms of x0, x1, x2, you should consider this one is say, okay now, this is say x1, and say this is x2. And again you just draw the parabola, okay, using these 3, okay, you will get another new estimated root, say x4, okay, then your answer will be, so next approximation will be x2, x3, x4, and so on. So in this way, ultimately you will reach this black point, that is the root, actual root. Okay, this is the point. You will ultimately, you can reach this root. Okay, maybe say xn, nth iteration. Okay. So since I have already told you 1.86, so it will firstly converges. Okay now, but little bit less with compared to Newton-Raphson, that is 2. Okay, so this is the graphical concept. So now we have to find the mathematical form, okay now, of this one. So these are the discussion of Molar method. Next one is the mathematical form, how to find the mathematical form of the Molar method. Okay, so in the previous slides, okay, what we have considered, now we have considered that, okay, x, this is the parabola, okay, f of x, this is the parabola f of x equals to, it is visible or not? F of x equals to a into x minus x2 square plus b into x minus x2 and plus c. Okay, so should have pen and paper. Okay, na? Since I have not written all the entries, you have to point and you have to answer it. Okay. F of x equals to a into x minus x2 square plus b x minus x2 plus c. Why you have considered x minus x2 this form? Okay, so that you have three entry x0, x1, x2. You have three unknown. You have three unknown. Okay, so what are the three unknown? I have already rounded that three. So this a, b, c are three unknown. X is the variable, and x0, x1, x2 are three initial approximation. Next slide. Okay. So since x0, you have already I think noticed that x1, x0, x1 and x2 are the points on the parabola, correct now? That means the parabola passes through these 3 points. Okay, that means the equation, parabola equation should satisfy these three at these 3 points. Okay, now? So f of x0 from 1, so this is the equation 1, previous one, this is equation 1. Okay, and this in this equation, if you put x equals to x1, sorry, x0, x equals to x2 and x equals to x1, this equation should give the 0. Okay, now? So you just see, but here it is f of x0, f of x1, f of x2 minus, if you take the right hand side, then equals to 0. So f of x1, f of x0, f of x1 and f of x2. What is the value of c? So without solving directly, you are getting value of c. Just equation number 4. Fine. Okay. So that's why actually we have considered this type of parabola equation. Okay. So from 4, you just check c is directly, you are getting c. Now now you have to find a and b, two unknown. So what we have done actually, 2 minus 3 equation, 2 minus 4, sorry, and 3 minus 4. Then these are the equation, 3 minus 2. Sorry, 2 minus 4 and 3 minus 4. What is 4? 4 is nothing. F of x2 equals to c, that one. So now just check it. Now, okay, f of x0 minus f of x2 equals to a, x0 minus x2 square plus b into x0 minus x2, and f of x1 minus f of x2, okay, equals to a, x1 minus x2 square plus b, x1 minus x2. So this is the equation 4 and 5. So now equation 4 and 5. Okay, fine. Sorry, 5 and 6 now. Okay. Now, okay, before solving this one for a and b, we will write in short form. Okay, now, or incremental form. Write down. So h0 equals to x0, x1 minus x0. You have not studied till now the forward difference and backward difference. Okay. So you have studied forward or backward differences. Okay. That's why I'm not using that concept. Okay. Now. h0 equals to x1 minus x0. Okay. Let this one, and h1 equals to x2 minus x1. You will just see what actually you have considered. Okay, x0, say x1 and x2. If it is like that, maybe reverse also, okay, no problem. Or anyway, so h0 is the difference between this one, and h1 is the difference between this one. Okay, so now del 1 is the increment of the functional increment, that is called actually central difference formula. Okay, you have not studied till now. Okay, it is in I think unit 4 or unit 3. I have to check unit 3 or unit 4 it is there. Okay, unit 3 maybe. Okay, so now del naught is f of x1 minus f of x0 divided by x1 minus x0. What about del 1? I have not written. If you are following, you can answer. Good. Very good. I will write now. F of x2 minus f of x1 divided by x2 minus x1. Fine. Good. Okay. So this is the one. Now, what is our target? To find, since we have already evaluated C, but till now these two are unknown. From okay, so we have to find A and B. Then only we can write the parabolic form or parabola. Okay. So now, okay, if you replace this f of x naught and f of x2, okay, f of x1 and x naught and x1 x2 using h naught, h1, del naught and del 1, I will show you what will be the next form. This is the next form. Okay, so from the equation 5 and 6, okay, we from the equation 5 and 6 previous one. So this is the 5, equation 5, okay, and this is equation 6, and using this 2 and using h naught, h1, a del 1 and del 2, sorry, del naught and del 1, we'll get this type of form. This is from equation 5. Okay, I should not give the name this one, but this is equation 6 for your understanding purpose only. I am writing here. Okay, now so this is from 5 and this is from 6. Okay, so now if you solve for A and B, what will be the answer? So A is this one, B and C. C I know, that's why I have written C equals to f of x2. What about A and B? It should not be in terms of x and f of x. That's why it is h and del naught. So now if you solve this one, these two equations for B and A, okay, what will be the solution for A and what will be the solution for B? Very simple. Why you are taking so much time? I don't know. You are finding, you are solving two equations, two unknown. Just second one multiply by h naught plus h1 and first one multiply by h1. You will get the value of A. Okay. So solving for A and B, we get, I will write then. Okay. Del 1, del 1 the A is del 1 minus del naught divided by H1 minus H naught, and B is A times H1 plus del 1, and C is f of x2. Okay, so you note down this one. Okay, you have to use this one. So now you have A, B and C. Okay, and since you have A, B, C, okay, A, B, C you have, so I think you can able to find the root of this equation, that is the solution. Okay, so what is the root of this equation then? A x minus x2 square plus b x minus x2 plus c equals to 0. So let x3 is the root, correct now? So if x3 is the root, okay, and then x3 minus x2, so it is let x3 is the root, then the expression will be like that: a x3 minus x2 square plus v x3 minus x2 plus c equals to 0. So now if you consider x3 minus x2 equals to x, then the equation x3 minus x2 equals to x, okay, then a x square plus bx plus c equals to 0. So that's why for solving x, that means for solving x3 minus x2, okay, so I will write this one there itself, okay, here. So the new equation, okay, I will write a x minus x2 square plus b x minus x2 plus c equals to 0. This is the equation, correct? So now let x3 is the root. So that means the new equation is, okay, a x square plus bx plus c equals to 0. The x is x3 minus x2. So what is the capital X? What is capital X? The formula is minus b plus minus square root of b square minus 4ac by twice a. You have studied this one or not? This one is known to you? Yeah. So x equals to x3 minus x2 equals to minus b plus minus b square minus 4ac by over, okay, twice a. So now I have written this is the x. Okay, that means, okay, I will erase it now. Okay, so let the answer is x equals to this one. Do you agree for that? X equals to x3 minus x2 equals to minus b plus minus b square minus 4ac divided over twice a. So now I have written minus twice c b plus minus square root of b square minus 4ac. Can I write that one? Yes or no? No. Okay. So what I have actually done, square root of plus minus square root of b square minus 4ac plus b. I have multiplied both numerator and denominator by this one. Plus minus b square minus 4ac plus b. Okay. Both numerator and denominator. Okay. Then you can check, you will get this answer. Okay. So yeah, this is one of the root, no problem. Okay. So now x is this one. Now what is x? Now x3 minus x2. So now I will erase it again. Okay. So the root of the new entry, that means x3, is x2 minus twice c divided by b plus minus b square minus 4ac. If you have doubt, you can write like that also, minus twice c. Means x3 equals to x2 plus minus twice c divided by b plus minus square root of b square minus 4ac. So this is the working formula for finding the root of the, that means new entry or new actually root of the next iteration, okay, or new one of the point of this 3 point, out of this 3 point, this is the 1 point x3 new point, okay. So after finding the x3 you can replace x0, x1, x2, okay. The new entry will be x1, x2 and this x3, that is. So all the formula, okay na, you should write, okay na, right now itself. A is this one, B is this one, C is known to you. So I will erase everything once again. So I will go back to the original form, okay na. So these are the important part, okay. You should, sorry, okay. These are the important part, x3, okay. And you already the another previous one, this part, okay. So I will write here, okay, using red or black. So these are the few important part for calculation purpose, okay. I have boxed all this part. So 1, 2 box. Here it is two more boxes, okay. So now, okay, so now you have replaced x2 by x3. So earlier x2 was the solution, now it is x3 is the solution. So what is the accuracy now? So to find, therefore we have to find the error. So it is epsilon is x2 minus x3 minus x2 by x3 into 100%, okay. So anyone can answer what is this error, percentage error or absolute error, or what type of error this one, okay. So now before this one you just tell me what is this one. Epsilon is x3 minus x3 minus x2. What is this type of, what is the error, this one, what type of error this one? This is the difference between these two, okay na. So what is this one? X2 minus x3, sorry, x3 minus x2 divided by x, relative error. What is this one? Good. And now what is this one? Percentage error. Good. Fine. So now, very good. Okay. So now I will write down, I will construct this table. So what will be the computational table? So once again, x0, x1, x2, initial approximation. Fine. Next approximation should be x, this one. So x3, that is x2 updated to x3. So it will be replaced like that. And x3 is the new. And next one, next iteration, it should be like that. X1 should be replaced. Okay, sorry. X1 will be like that. Here it is x3 should be there and x4 is the new. So these are the new, the actually rounded one. Okay. So if n is the iteration, okay, if n is the iteration, then what are the table actually? That is x n minus 2, x n minus 1 and xn. So n should start from 2. Okay, you can check that one. Xn plus 1 and error. This is the table. Okay. So now before finding this table, you should know when you should stop. Okay, now the stopping criteria or termination criteria. What is that one? Now when epsilon, that means the error is less than the recorded or the specified error. Okay. So it will be depend on the criteria given, okay, for a particular problem. Okay. If it is not given, you can consider 1%, less than 1% or less than 2%, it's enough. Okay. So I will now check. So this is the computational table. So x naught, first case, initial approximation, x1 and x2, you are going to find x3 and you are going to find epsilon. This, the circle one actually unknown to you, you have to evaluate these two. So now n3, that means next iteration. What should be here? You just check x3, n equals to 3 means x1, x2, x3. You have to find x4, okay, and epsilon, okay. So this in this way you have to proceed. I think you have already noticed that, okay, all the equations or all the calculation part, okay now. Sorry. For all the calculation part, it is actually denoted in terms of x2, x3, x0, x1. Correct now? x0, x1, x2, and finally the x3. But in table you are writing x1, x2, x3. So what you have to consider? This is the new x0, this is the new x1, this is the new x2. Fine. I should write in different color, then it will be better. Okay now. So you have to consider this one is the new x0, this is the new x1, this is the new x2. Any doubt? So now we will consider one problem. Okay now, I will not do anything, you can check. Okay, all are empty, only I have made the structure of the problem. Okay, so you should have pen and paper. Okay, till now only one fellow responding. Okay, now use Muller method to find a root of the equation x cube minus x minus 1 equals to 0. Fine. So now, let it is given that, okay now, that 0, 1, 2 are the initial approximation. Okay, or else you can check the root, possible root, if it is say 2 or 3. What is the difference? If I ask what is the difference between, okay, Muller method and regular falsy method? Okay, that is one. Till now we have discussed a lot of things. Okay, now some other fundamental difference. Can you tell what are the other fundamental differences? At least one difference is there. Okay, so that should be actually that is actually very important difference. Okay, what is the Muller method and regular falsy? It is 3 point, it is 2 point. Fine. Anybody else? Should I give you hint? Okay, fine. Here? Yeah, fine. Now I need one more answer, actually one more answer from you. Is it visible? Okay. What is the root? It is black point, correct now? It is written root, correct? And you just check where the approximations are, x0, x1, x2. Is it lies between the root belongs to actually? No. The root is outside the initial approximation, x0, x1, x2. Can we consider x0 and x2 as the initial approximation for the regular falsy method for this graph? Okay. That means what is the advantage of this one? You can say that the root no need to lie in the considered initial approximations. Okay now, it may be outside of the initial approximation. Fine or not? It's okay. So this is the vital difference. So that's why, yeah, just check it. You can check x cube minus x minus 1 equals to 0. What are the possible roots? Okay, directly using your what is that calculator. What are the possible roots? So here it is, the root is outside, but your points are maybe inside or maybe outside, no problem. But here the root must be inside. Okay, what are the possible roots? Any real root is there? Okay, what is the value of that real root? 1.324. Okay, for this approximation or this initial approximation, 1.32 is inside the initial approximation. Okay, na? But it is not required. Okay, na? You can take anything. That means here it is. You can take that -1, 0, and 1 also. Okay, no problem. So now I have already shown you the graph. Okay, that figure. Okay, and now this is the initial approximation 0, x1, x2. What is the f of x naught? That means f of 0 minus 1. So all this input I need from you. I don't have any solution with me. Okay, na? So be careful. What is that one? F of x1 minus 1, fine. And f of x2, that means f of 2 what is that? 5. Okay, fine. Now I will h naught. Do you know the formula is not? X1 minus x naught. X1 minus x naught is 1. And H1 is x2 minus x1 is 1. Fine. What is the value of del naught? F of x1 minus f of x naught divided by x1 minus x naught. And similar this one, I will not write second one. Okay, I will write f of x2 minus f of x1, x2 minus x1. Yeah, tell me the answer. 0. And f of, sorry, del 1, 6. Fine. Now you just check it. Sorry. Yeah. What is A? You can note down now itself. Okay, now. A is this one. Okay. And x3 is this one. These two box you need actually. Quick. Find it. Yeah. H1 and H0. No problem. It's not a problem, I think so. Okay. We'll check it. Oh, H1 and H0 both are H1. What is the value of H1? Okay, both are equals to 1. Then we have to change it. Okay. Okay. Next. Yeah. So let this one is 1.5. Fine. Okay. Even you can consider 3 also. No problem. Okay. So let you consider 1.5. Then all the entries will change. Okay. Here also it will change. It will be different. Okay. So x2 is 1.5. 1.5. Okay. So the answer is 0.875. Okay. Now h naught equals to 1. H1 is x2 minus x1. 0.5. Okay. So this is 0.5. Now del naught f of x1 minus f of this one will remaining same, correct now? This one will, there is no change, but this one will change. Okay. So what is del 1? .75. Fine. Now I will go back previous one. So these are the A, B, and C, and then you can find x3. So these are the formula you can note down now, and then I need the answer, so I will go there. Okay. So next. Tell me the A, B, and C. The A formula is, you know the formula, correct now? Del 1 minus del naught. I can write this formula. Okay, h1 minus h naught. B is A h1 plus del 1. And f of x, that's 3 is known. That is f of 0.875. Next. 0.875. That is, what about A and B? B equals to 0. Okay, fine. Okay, so if B equals to 0, now fine, now you can find the x3. So what is the x3 formula, you know, correct? So therefore x3 equals to x2 minus, okay, sorry, plus minus twice c divided by b plus minus square root of b square minus 4ac. Now tell me the first this part. Okay, so therefore x3 equals to x2 is, you have considered x2 is 1.5 plus this one. So you know A, B, and C both. Okay, 1.5 1584. No, acha, B is 0, correct. Okay, no problem. Okay, so you are getting all plus minus both. Then also it will be plus minus only, but minus we should not consider. So answer is actually plus minus. Okay. Okay. Oh, I see. I see. Okay. Okay. Correct. No. Then no, a little bit problem. Okay. Now, just you tell me this part. Yeah. This part you tell me. The 0.3415. Correct. Yeah. If you add it, then the solution is 1.8415. Fine. And if you subtract, then the answer is 1.1584. Fine. Okay. Now you check which one is less error. You consider that one. So now we have to find the epsilon. Fine. So next one is next page. Now find. Now epsilon is, what is the answer? Now x3 minus x2 by x3 into 100%. So what is the answer? You have 2x3. Okay. And see, of course you know the solution if you are 1.82. Okay, it is less only, but till you should go for one more stage or one more iteration. Okay. Okay, x3. Okay. So now you just tell me the epsilon value. Okay, na? Fine. Okay, no problem. How much it is? 0. 22.7%. Okay, so it is okay. Use error, so we have to find one more iteration. Okay, we should find one more iteration. Okay, so next iteration. Okay, so one more iteration we have to find. So now let x0 is, so I will go back. Okay, so now x0 should be 1.5, and then next is 1.84. Okay, or 1.1584. So 1.1584 we will consider. Okay, now previous one. Next, so it is 1, x1 is 1.5 and x2 is 1.1584. Okay, 1.1584. So this is the, okay. So you listen, You might have question, sir, it is 1, then 1.5, then 1.1584. Okay, it's not a problem, it's a parabola. Okay, now 3 points. Okay, it may be here also. Okay, so the parabola is like that. Okay, now if so the 3 points you have considered like that. Okay, so it is less, then increase, it is decrease, then again increase, no problem. Okay, so these are the 3 initial approximation now. Okay, now you have to find f of x is a x minus x2 square plus b x minus x2 plus c. Here x2 is this one, 1.1584. Okay, so what are the from here? So we have to start from here again. So all this one. So this is the iteration, say iteration 0 or iteration 1. We can say iteration 1. Okay, now same thing, iteration 2 we have to do. Okay, so iteration 2. Okay, so second iteration. Now to find f of x naught, so f of 1 you have already, you can copy from that. Okay, now f of x1 you have this one also, 1.5. so only you have to find x2, that is how much. Okay, now so f of x naught, I will write next one. Okay, so for the next iteration, f of x1, sorry x naught, f of x1 and f of x2, what are the answer? Minus 0 point. Now h naught, then h1, then del 1, sorry del naught, then del 1, and after that, okay, after finding all this one, what about the other? No one is responding, people are not here or not doing, I don't know. B, C is known, minus 0.6039. What is h naught? .5. Okay. H1 okay, del 1, sorry, del naught and del 1, 3.75 and del 1, okay. Now A and B, the formula is del 1 minus del naught by h1 minus h naught. B is A h1 plus del 1. .688, okay. B Okay. So now you have A, B, C. So like earlier previous iteration, you can find the x3. Okay. So x3 is x2 plus that formula. Next I will write the formula. Therefore, new x3 is x2. x2 means x2 value, you know that. Okay, na? x2 plus minus twice c divided by, okay, divided by, the formula is, I will write once again, b plus minus square root of b square minus 4ac. What is the answer? So x2 is previous one, x2 is 1.1584. 1.1584 plus minus that value is, what is the answer? So once again you will get two value, one is positive, one is negative, or maybe both are positive. Okay. So you have two values, that two value you write. Okay. Twice c upon b plus minus square root of b square minus 4ac. Zero point. Okay. But b is not 0, so I think, what about the b? Why you are getting this type of solution? Plus minus both same, should not be same, I think so. Why? B is there, no? So okay. Oh. Okay. So okay, just check it once again and tell me. Okay. Another one? Okay. 4.5643 plus or minus 4.3784. Okay, fine. So now you just check this result, you just tell me this one after considering plus and after minus also both. So 2x3, what are the x3 values? 2x3 values would be there. Now you tell me the 2x3 values. Therefore x3 is 12. One is 1.1584 minus 0.26465 divided by 4.5643 plus 4.3784, and once again it is 1.1584 minus 0.26465 divided by 4.5643 minus 4.3784. .1288. Another one. Minus is coming, so that one we will not consider. Okay. But okay. One is minus is coming, so this is the answer. Okay, now so x3. Therefore x3 is 1.1288. 1.1288. Therefore epsilon is x3 minus x2 by x3 percentage 100. So the answer is 1.1288 minus that is 1.1584. 1.1584 divided by 1.1288 percentage. What is the answer? 2.6%. It's fine, but till you need one more iteration. Okay, so this one is fine. 2.4 or 2.6% is fine. Okay, you can stop here, but I think you can find one more. So this is the approximate solution x3. Okay, after 2 iteration, correct? So you can go for one more iteration, then you can check it will be less than 2 point, I think less than 1% iteration. Error. Okay, fine. So I will not do here another iteration. So go for third iteration. Okay, so I will not do. Okay, now and check your answer. Okay, so let epsilon should be less than 1% for this problem. Okay, this is the criteria. Let us see. Next, homework. Okay, yeah, homework is like that. Use Muller's method to find a root, okay, of the equation x cube minus 13x minus 12 equals to 0. Okay, using the first approximation. X0 is 4, x1 is 5, and x2 is 5.5. Okay, sorry, 4, 5, no, 5.5 x1 is say 5.5 and x2 is 5, this one. So this is the first problem. Second problem, okay, second one, okay. Find the root, find the root of, okay, root of x cube, okay, minus 3x plus 2 equals to 0 by Muller method, okay, up to fourth iteration, up to fourth iteration. Rule. And number 3, last one, okay, find the root of, okay, x cube minus x minus 1, okay, equals to 0 with initial, just now we have done this problem, okay now. So now I am changing the initial condition with the initial condition, with the initial approximation, x naught is minus 1, x1 is 1, yeah, and x2 is minus 1, 0 and 2, minus 1, 0 and 2 is okay, minus 1 to 0, 1 and 0 to 2 is fine, 0 and 2, minus 1, 0 and 2, minus 1, 0 and 2, okay. These are the 3 homework, okay. Minus 1, 0 and 2, okay. So okay, so I will not check over, okay. These are the 3 homework, no need to submit, okay, for practice purpose only.